Welcome back. Part 2, finding domain from an equation.
Now let's find the domain of v of x. V of x has domain issue number 1 because there's an x in the denominator. So I'm setting the denominator not equal to 0. So then I'm going to set each piece equal, or I should say not equal, to 0. And then I'm going to solve each one of these mini equations. By adding 5, we find that x cannot equal 5. When solving x squared plus 4 does not equal 0, we start by subtracting 4 from both sides. And then we want to take the square root of both sides. But when you go to square root both sides, you're taking the square root of a negative. And those are imaginary numbers. Those are not graphable. Those are not real solutions. So we don't have any numbers that we can choose off of the number line to put into x squared plus 4 to make that piece equal 0. So this equation doesn't give us any numbers to leave out. So all we want to do is not use the number 5. Taking a closer look at how we're going to write the answer for the domain using interval notation, we cannot use the number 5, but we can use everything to the left and the right. So writing this across from left to right, we can use parenthesis negative infinity up to 5, parenthesis to leave out the 5, union, parenthesis to continue leaving it out, but we use everything to the right of 5 up through infinity. Now we found the domain of all of the functions where x was in the denominator. So now let's tackle all of the equations that had an x underneath an even root. Let's begin with m of x. What we don't want to have happen is we don't want to take the square root or an even root of a negative number. So to make sure that doesn't happen, we want to make sure we only use x's that make the radicand 0 or positive. So we're going to set the radicand x plus 9 greater than or equal to 0 and solve by subtracting 9 from both sides. So we can use numbers that are greater than or equal to negative 9. Let's take a closer look at how to write this using interval notation. X is greater than or equal to negative 9 means that we can use the number negative 9, and we can also use anything to the right of negative 9. So let's write it down from left to right. We're going to have a bracket on negative 9 to include it, and then we will continue using all numbers to the right, so through infinity, parenthesis. So as long as we substitute numbers, negative 9 or larger, into m of x, we won't be taking the square root of a negative number. Let's take a look at h of x. The radicand is x minus 1. So following the rule, we're going to set the radicand greater than or equal to 0. Add 1 to both sides to solve. So our x's need to be greater than or equal to 1. Let's take a closer look at how to write this using interval notation. So we can use the number 1, and we can also use any number that is greater than 1, so everything to the right. Writing this down in interval notation, thinking about it from left to right, bracket 1 to include it, through infinity, parentheses. As long as we choose a number from 1 to infinity and substitute it into h of x, we will not take the square root of a negative number. All right, r of x. We're setting our radicand greater than or equal to 0. When I go to solve this one is going to be a little trickier, so some review of Algebra 2. Because this inequality has an exponent greater than 1 on the x, we have to find critical values. So to find a critical value, you just rewrite the inequality 9 minus x squared greater than or equal to 0, but instead replace the greater than or equal to with just an equal sign. When we solve this equation, we will have found the critical values. So I'm adding over x squared. When you take the square root, don't forget you get positive and negative 3. These numbers that are critical values go on a number line. So I'm going to make a number line and plot negative 3 and 3. Next, I'm going to test numbers to the left of negative 3, in between negative 3 and 3, and numbers after 3. So we're breaking up this number line into 3 pieces. You can pick any number you want to the left of negative 3. I'm just going to pick negative 5. You could pick any number to check between negative 3 and 3, and I'm going to select 0. And then I want to pick any number to the right of 3, and I'm just going to pick 5. To test these numbers, you're substituting them back into that 9 minus x squared. So here I go, substituting in negative 5. And then I'm going to substitute in 0 and substitute in 5. When I evaluate each of these expressions, that first one where I substituted negative 5, I get negative 16. The most important part there is that it's a negative answer. When I substitute 0, I get positive 9. Most important part that it's a positive. And substituting 5, I end up getting negative 16, most important part, negative. So no matter what number that I substitute into 9 minus x squared, that is to the left of negative 3, I will get a negative answer. And any number between negative 3 and 3 I substitute, I'll get a positive, and anything to the right of 3, I will get a negative. I'm looking for numbers that are greater than or equal to 0, so those are positive. So the only section that's working is between negative 3 and 3. But not only is it greater than 0 that I'm looking for, it is greater than or equal to 0. When you substitute the number negative 3 or 3, we get 0. So the numbers that are going to make the square root of 9 minus x squared, they're going to make it so that that radicand is not negative. It's going to be numbers between negative 3 and 3. One more time, I said that kind of funny. So if you substitute negative 3 through 3, any of those numbers into r of x, you won't be taking the square root of a negative. Lastly, we're going to tackle the function w of x that had 2 domain issues. You just want to take care of each one separately, so beginning with the fact that there's an x in the denominator, and we don't want to divide by 0, we're going to set the denominator not equal to 0 to find out what number or numbers we shouldn't use. So x minus 4 cannot equal 0. Then I'm going to add 4 to both sides. So we should not use the number 4. Next, we want to take care of the other domain issue, which is there is an x underneath an even root. So we're going to set the radicand, that's what's underneath the root, x plus 3, greater than or equal to 0, and these are numbers that we can use. Solving this inequality by subtracting 3 from both sides, we get x is greater than or equal to negative 3. We want to merge both of these statements. So x does not equal 4 means we don't want to use the number 4, and x is greater than or equal to negative 3 means that we can use the number negative 3 and anything that's bigger than negative 3. I'm going to put these two things on the same number line just to help you visualize that. Okay, so we do not want to use the number 4, so I'm going to put a no above the number 4, but we can use 3 and anything to the right of it. But that can't use 4, we've got to remove the 4. So let's record it in interval notation, so bracket negative 3 because we're including that. And we're going to use all the numbers until we get to the number 4. We're leaving out 4 by putting a set of parentheses there and then going through infinity. So if we substitute a number from this interval back into w of x, we know we will not be dividing by 0 or taking the square root of a negative number. All of these numbers work. Back to the summary of the rules. A reminder as you go into your homework, just look at your equation and ask yourself, is there an x in the denominator? If there is, set the denominator not equal to 0 and leave those numbers out. If there is an x underneath an even root, well then set the radicand greater than or equal to 0, and those are the numbers you can use. You will not come across any logarithms, so if the equation you're looking at does not have an x in the denominator or an x underneath an even root, well then you know the domain is all real numbers.